In this section, we're going to look at the QuickTimes predetermined time application to come up with an estimate to see how good the times are we have from our time study. So for instance, this aside and get next here, the operator puts the part away, gets the next one and brings it back and is ready to start here. So what I'm going to do, you can see the time for this one is 4.338 seconds, right? If I want to switch it to minutes, I can click on minutes. You'll see 0.072 minutes here. And what I'm going to do is I'm going to click on my QuickTimes here, right? And there you can see the 0.072 is brought in. And now we're going to describe what actually happens during that process to see how close that is to what we think it should take. Right? Now this is actually using the metrics version of our QuickTimes. In other words, it's going to work in centimeters and kilograms. Obviously we have an English version which would work on inches and pounds. So don't concern yourself with this. But let's say the guy, first of all, he places the current part away. He places it away with a loose fit. How many centimeters? Well, I'd say 18 inches, about 45 centimeters. Here's the time, 1.08 seconds, right? Now that is actually coming from a MTM1 backup here. I can show you that backup right here. If I move this aside for a moment here and just bring up this guy. Okay, so you can see here, here's the times. It's all based on the English version. So PL18 is 18 inches. There's a constant part of the motion, which is basically position. The variable refers to the different lengths of the moves. How far are you moving it? What the total TMU is. Now, 1 minute is equal to 1,666.7 TMUs. So this number of TMUs, time measurement units, is rounded to 35, which gives us so many minutes, which gives us so many seconds. And indeed, that number of seconds that you see there is the number that appears there, 1.08. That's the one that's coming right from, jumping around here. That value there is that value right there. So we have a full MTM1 backup for all of the data that we are using, and we provide you with all that backup. So the operator has placed the part. Now he's going to get the next one. So they have to get a part. Let's say it's a jumbled part, and it was 6 inches away, so they're obviously putting it down somewhere close, and then he's going to bring it back. So this time he's placing it with an exact fit because he's positioning it right by the machine. You can see it in the background, and he's going to come back the same 45 seconds. So there what you can see is we actually are within 1% is what we've got from the synthetic time versus the observed time. So the operator in this example is using a very good method. It cannot be improved upon. So we're very happy with that. We can save that then. And then what we can do is we can go to the summary area, and we actually have an option to export the QuickTimes. And if we send it out to Qt1, let's say, and overwrite the one that's there, then you can see the data has been sent out. So here's the average time, and there's the QuickTimes value, and here's actually the QuickTimes sequence that goes in there as well. So we can actually write that information out to a supporting file. So what have we done here? We basically have used the QuickTimes generator. I highlighted this particular one here, called the QuickTime generator, to confirm the method that the operator is using. Again, you're looking for opportunities to improve the process by methods analysis and maybe estimating how long it would take if you did something a little bit differently.